All right, good morning, everyone. Today, we're just going to be practicing through these trig-related rates word problems that we started yesterday.
Young Goku. Bro, I was so mad. You know, like, oh yeah, he missed it though. Look at almost hurt our young
All right, we're going to skip the first two problems because these don't really involve the calculus applications that we need. So this is off of the 10 problems worksheets. So let's go to number 3. Okay, so I'm going to work through the first problem step by step. See if you guys have any questions, and then just practice. Give you guys a chance to practice each problem, and I'll follow up with the solutions. So we have a triangle here. It's a little hard to see, so let me redraw this. Okay, so there's our starting diagram here. It says the angle theta is increasing at a constant rate of 6 radians per hour. This sentence, can we identify what that 6 is referring to? Which variable is that referencing? Good. Right, we see 6 is in reference to theta, but it's not just theta, right? We see the word increase, we see rate, we see radians per hour. We know there's time component involved, so d theta dt. And another word is increasing, right? So that tells us that we're dealing with a positive rate, so positive 6. Okay, next sentence. What rate is the side of length x increasing? So what is that talking about? Good, dx dt. That's the unknown. That's our goal. When x equals 6 feet. Okay, so we'll put that down as well. Okay, I want us to be careful with this value because this value is not going to replace this x initially. Okay. The reason why the x is given to us and theta is given to us is because they're telling us that these are values that are changing over time. And we see that dx dt is what we're trying to ask for. So if we plug that 6 in too soon, and we lose the ability to get the variable, this dx dt, to show up. So we're going to use this, but not initially. Okay, so now the next step is we've gathered all the information. We have the triangle in front of us. Our next step is identifying the trig equation that will allow us to hit all 3 pieces of information here. So do we want to use sine, cosine, or tangent? Sine, right? Sine of theta is opposite over hypotenuse. Okay. We want to find a derivative, but maybe I'll do a little bit of cleanup on the right side. So sine of theta, I'll push that 10 out as 1/10. Now we can focus in on our derivative. So as a reminder, sine's derivative is cosine. And this is where related rates is going to come into play, right? This is where our variable time is going to begin to show up, right? d over dt. Right now, time is hidden, but when we find a derivative, it's going to begin to showing up. So sine theta becomes cosine theta d theta dt. 1/10 x, the derivative of 1/10 x is just going to be 1/10, but then x is going to produce its own differential, so dx dt. This is the one calculus step in our problem. Any questions up to this point? Good. So let's take a look at what we have. dx dt, that's what we're looking for. d theta dt is given to us. But now what's sticking out is this cosine theta, right? We don't know what to do with that cosine theta, not yet. So, but we're going to find a complete replacement for cosine theta. Okay? We're not going to worry about theta. We're going to replace the entire cosine theta. And to do that, we're going to create a second triangle, and the second triangle with all the sides labeled so that we can find a ratio for that cosine theta. So here's my second triangle. This x is now we're zooming in on just a moment in time. So this is when we're going to use that 6. That 6 is now going to be come into play for us. All right, we still need to find this third side. So how do I find this third side here? Yeah, Pythagorean theorem. A squared plus b squared equals c squared. A squared is 64. A is equal to 8. So now we can find a suitable replacement for cosine of theta. What's cosine of theta equal to?
8 over 10.
Good, 8 over 10. Adjacent over hypotenuse, we can reduce that fraction. So now we're in the clear because we have everything that we need. Now we're just plugging in and solving for our missing variable. So cosine theta gets replaced with 4/5. d theta dt. Usually we're looking for d theta dt. In this case, this is given and we're trying to find another variable. So 6. If I multiply both sides, if I divide both sides by 1/10, that's the same thing as 1. We get 240 over 5, or you can think of it as 10 and 5 reduces to be 2. 2 times 24 is 48. And what's our unit of measure for dx dt?
Feet per hour.
Good. X is in terms of feet. Time is in terms of hour. Okay. We only do radians if we're dealing with angle, but here, finding a linear related value. Okay. Any questions with the steps? Okay. Let me help us through the beginning parts of number 4. Okay, does anybody still need to look at number 3? Okay, here's number 4. Let me zoom in a bit here. Okay. When we read this problem, we want to figure out which value or which part of the triangle is the constant and which part of the triangle is moving or is changing. Whatever is constant, we can go ahead and put a number for it. Whatever is changing, we want to make sure that we put a variable in place of that, that length. Okay, so a camera is on the ground 200 meters away from the base of the hot air balloon launch. The balloon is rising at a constant rate of 10 meters per second. How fast is the camera's angle of elevation changing when the balloon is 150 meters in the air? So What's unchanging that we can go ahead and put into our diagram? Good. This is unchanging, right? 200 meters. Okay. What part is changing? Okay. The balloon height, right? This is changing. We know theta is changing as well. Now, all the information that's given to us is in relation to the vertical component. So we have nothing for the hypotenuse. So we're going to focus our attention on just here. So I'm going to call this y. Even though they tell us the height at a moment in time, we don't want to put a constant for that, right? We want to save that for later. Okay, so let's see if we can gather some more information from the problem. The balloon is rising at a constant rate of 10 meters per second. So what can we assign 10 meters per second to?
dy over dt.
Okay, dy dt. Positive 10 because this was increasing. How fast is the camera's angle of elevation changing? So we're looking for d theta dt. When the balloon is 150 meters in the air. What's that? Y. But we're saving this for later, right? This is not going to go in our diagram. Okay. All right, we should have enough information. Look at your diagram, decide which trig equation you want to use, and then start working your way to your answer. So I'll come around and check your progress. Here is, well, let's make sure we're on the right track here. Which trig function are we using? Tangent. Okay. As a reminder, tangent's derivative is secant. So once we have our tangent equation, we can get it ready for the derivative process, push that 1/200 out in front. Tangent becomes secant squared theta, and this is where our time component is going to start coming out. D theta dt shows up, dy dt shows up. Okay. We're trying to look for d theta dt we can use from the beginning of the problem. So now we got to do some additional work to figure out a suitable numeric replacement for secant theta. So we go ahead and we draw our second triangle, fill in the appropriate sides. We should have two sides given to us, and we can find that third side using Pythagorean theorem. Now we're going to find the replacement for secant theta. So secant is hypotenuse over adjacent. So 250 over 200, which is 5/4. Now we should have everything that we need to plug in and solve. Secant gets replaced with 5/4. We're squaring that. dy dt gets replaced with 10. We divide the 5/4 over to the other side, make it 4/5 squared. Use a calculator, either 0.032 or 4/125. We're dealing with the rate of change of angle measure, so it's radians per time unit. Okay, questions here. Number 5. Does anybody still need this? Okay, you guys good? All right. Number 5. Okay, I'll help us draw the diagram here. We have a kite that's 40 meters above ground, moving horizontally at a rate of 3 meters per second. Okay, so here's my kite. It's going to stay at a constant height of 40 meters. At a rate of 3 meters per second, so it's moving horizontally, which is related to this x here. At what rate is the angle between the string and the horizontal decreasing? So the string and the horizontal is here. When 80 meters of string has been let out. Okay. So this 3 meters per second is going to be related to this horizontal motion here. So we're going to call that 3 meters per second a dx dt. Okay, just like before, we're looking for d theta dt at the moment when 80 meters of string has been let out. So the string from the person on the ground to the kite is here. So I'll call that z. Z is equal to 80. So the question is, why is it a better move to do 40 and x instead of 40 and z for our starting triangle? What's the benefit of this?
Because x is going to be moving, it's going to give you like the dx.
Yeah, it's because of this information, right? Because if we're starting with z, we're going to run into a dead end because eventually we're going to need dz dt, and we don't have enough information to get dz dt. So this z equals 80 is going to be helpful down the line when we create our second triangle. But this dx dt is really is going to be telling us this is the better fit for our initial diagram. Okay, so see if you can go from here. Build your trig equation. which equation can we use?
And
Tangent theta. Okay, there's something a little strange about this equation. I want to make sure we can see that. Is the adjustment that we need on the right side here. Before we find the derivative, what can we do on the right side so that we can avoid quotient rule?
I'll separate the fraction 1 over x.
Yeah, well, I guess we could do that and go through product rule. But let's just, yeah, if we just bring it up, then we can just be able to rely just on power rule. So that's just going to make it easier for us. Yeah, so start here and find the derivative of both sides. Okay, remember tangent is secant squared, right? Okay. Okay, here's what your derivative should look like. When we find the derivative of 40x and -1, the x doesn't disappear because once you bring that -1 down, we start to subtract 1 from that exponent. So we get a -2. Do a little bit of cleanup, and then we can move to building our second triangle to find a replacement for secant theta. How that 80 is going to come in and be useful for us. Here's my triangle information. If you want to leave it just as square root of 4,800, that's fine, because eventually, yeah, things will reduce. But I just wrote it as 40 root 3. Okay, once I have that, then I should be in the clear. Everything I need is now found. We can figure out the only variable missing is now d theta dt. Yeah.
Is it okay that when like doing the, wait,
Over here, you left this at square root of 4800.
so I don't remember what I did. Oh, so when finding the x on the triangle,
Uh-huh.
I did 8 squared minus 4 squared, and I got 4 root 3, and I put that underneath it, and I still got the same answer. I don't know how, but
I guess because you're dealing with ratios, so you divide it by 10 for each of these sides.
yeah. Oh, that's true, because it's,
Yeah, that's true. Well, the ratio is fine, but the problem is that when you get to this x value, if you don't have the exact x value, it's not going to give you the right answer here. So if you want to just leave it as square root of 4800, I think that's fine. Let's see, all right, 48. Yeah. And just use this value instead for your secant theta. If you don't want to go all the way down to 40 root 3. Even though that's pretty ugly, once you get it into secant squared theta, the radical will go away. And if you square that, bring it over, it should clean up nicely. We still give you negative 3 over 160. Okay, any questions with 5? Okay, let's look at number 6. So a man stands 12 meters away from a flagpole. So here's my flagpole here. He holds on to a long rope attached to the flag. As the flag is raised at a rate of 10 meters per minute, the rope runs tautly through the man's hand so that it is always kept straight. Find the rate of change of the angle between the rope and the flagpole. So the angle is a different location here. It's up top. At the moment when there's 24 meters of rope between the flag and the man. But we know this 12 meters is going to stay constant. So let's start here. Build your trig equation. Identify values for variables. Okay, we should be using tangent, right? Tangent. Okay, here's our derivative. Find the missing side. Find secant theta. And then progress our way to our answer. Any questions here? Let's look at number 7.
Mr. Yang,
Yes, question.
can our answer be in decimal form, or do you prefer fractions?
You can do decimal if it comes out to be an exact value. But if it's a repeating decimal, then I want a fraction.
Okay.
So this is a repeating decimal, so leave it as a fraction then. Okay, here's number 7. Okay, so a man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path. And it's kept focused on the man. At what rate is the searchlight rotating? When the man is 15 feet from the point on the path closest to the searchlight. So we know that this value is changing. Theta is changing, so we can call this x. So start here. There's your triangle. Okay, what do we have to be careful about this 4 feet per second here? Or what did you assign this to be?
To the x. Assigned to the x.
But it's a speed though, right? So
Yes.
dx dt. But is dx dt just going to be 4? what's happening to this length?
-4.
Negative.
Change
Decreasing. Negative, that's right. Negative. dx dt is -4. So the direction is going to the right, but what we're concerned about is what's happening to that length of the triangle. Okay, we should have picked tangents as our trig equation. Build your second triangle, Pythagorean theorem, find the missing side. Okay, any questions with 7? Okay, let's do one more, number 8. Okay, so we have a rowboat pulled towards the dock by a rope, and it's directly 6 feet under the dock. The rope is being hauled in at a rate of 2 feet per second. At what rate is the angle theta changing when 10 feet of rope is out? So let's start with this diagram here. Theta is here. This is staying constant. And the rope is what's changing. Okay, what did you assign this to be? The rope is hauled in at a rate of 2 feet per second.
So in CC,
Mm-hmm. Positive or negative? Good, negative, right? This, as a boat, as the boat gets dragged in closer, this rope is getting shorter. Okay, which trig functions you choose? Cosine, yeah. All right, finish up the problem here. The right side, I'm going to bring that z up, make it a power rule problem rather than a quotient rule problem. Cosine's derivative is negative sine. Fill in the size of the triangle. 8 is going to be the missing side. Sine theta equals 8/10 or 4/5. Put that into our equation. Keep track of your negatives. Units of measure, radians per second. Okay, any questions here? All right, so tomorrow we're going to do inverse trig derivatives. I'll return your chapter 5 test to you. For those of you who are interested and want to do recovery, I'll give you details for that tomorrow. Recovery test is next Wednesday. The trig quiz over these two topics, derivatives, related rates, and inverse trig, is next Tuesday. And recovery for the trig quiz is going to be within the final exam. So within the final exam, we'll have a section with trig derivatives. And if you do, so I hope to return this back to you. If you want to do recovery, you do the recovery work necessary, and then if you do better on that portion of the test, then I'll use that as a replacement for your as your recovery for your trig quiz. Okay, any questions?
Mr. Yang?
Yeah.
If we exempted the fall exam,
Yeah.
are we able to just, like,
You don't have to come to school then.
okay.
Yeah. Yeah, if you exempt, I'll probably have as we get closer to it, I have students let me know if they want to exempt out of it, so I don't have to send it out to you or prepare for that test. Yeah.
Will the recovery test be during class Wednesday?
No, the recovery test is going to be 7:15 or 4:30
Got it.
On Teams. Yeah. Just like before. Okay. Any other questions? Yeah.
What is that? I guess that's a Tuesday, that 7th period and fall exam day.
Oh, right. So this day, it's 7th period exam is going to be from 8 to 10, and then the rest of the school day is going to be kind of mixed. The order is all kind of scrambled, but every class period is like maybe 35, 40 minutes, something like that. So yeah, still a full school day, but then 7th period exam is going to take up the first 2 hours of the day.
So we didn't have 7th period.
Right. If you didn't have 7th period, then you would just come in later. And then these are all half days, 16th, 17th, and 18th. All right, if you're on Teams, have a great day. See you guys tomorrow.
Mr. Yang, I have a quick question.
Sure.
So once we finish the quiz, do we not, and like we're not taking the fall exam, so we don't have to come to school or come to this class after we take the quiz, right?
Exactly, yeah. But I'm
Okay.
going to ask you to send me a text remind so that I know that you're exempting out of that exam, just so, yeah, just for my information. But yeah,
Okay.
you don't have to come to school these days.
Okay, thank you.
Okay,